SOLIDWORKS Inspection Professional adds additional enhancements to the software, which allows you to import CMM data or to directly record any measured values and export them at the same time with your characteristic report. So to take a look at these different options and features, let's go to the Home tab, Options, and make sure that our SOLIDWORKS Inspection Professional tools are turned on by making sure that this Measurements Input and CMM Data Import checkbox is turned on. If you do not have a license for SOLIDWORKS Inspection Pro, this option will not be available to you. So we'll go ahead and say OK there, and we'll see two new panes that open up on the right-hand side, our CMM Data Import and our Measurements Input. If we knew what the measurements were, or if we had a hand micrometer or hand calipers and we're measuring these parts manually, we could come in here and add a column of data and then just start keying in our results. So for example, here a 0.344 is going to be very close to that upper limit, so it gets a yellow. Perhaps a 670 here gets us green, and so it passes, and of course it's color coding both our PDF and the preview of our final Excel report long before we ever actually export them. Now that said, if we were not using our traditional hand methods of measuring a part, you could also capture any dimensions off of a digital micrometer or digital caliper with that USB cord capture by simply highlighting the characteristic that you want to measure and then coming over here and hitting the capture button so whatever you're measuring is actually put into the cell in your measurements input column. Now the alternative is to use CMM data, and that's what we're going to use in this example. So I'm going to remove this column of data here. And the first thing we're going to do is check on the template that we're going to use for the CMM Data Import. If we take a look here, there is a button on the toolbar inside of the CMM Data Import section called Settings, and currently it's set to the PCDMIS.xml template. This is the third and final different kind of inspection template that you would use to create your reports. The first being the project template that sets all your default balloon settings, the type of font style that the OCR tool is looking for, your default tolerances, whether they're by precision or range. Your second template would be used to create your Excel reports, and your third template is what's used to import your CMM data, and that's what we're looking at right here. This is that third type of template. Now the first two are created by the user. That's you. The third type of template, the one that we're taking a look at here, the CMM Data Import, this is actually created by your VAR. And so you actually would call in to Hawkridge support, you would request for us to create one of these templates for you, and the only thing you would have to give us is an example of the exported material that comes from your CMM machine. So an RTF, a Word, a TXT, an XML, a CSV, any of those different file types that are exported from your CMM machine will then be used to create the template that you'll use to read that data in. In our case, we have the PCDMIS.xml option here, so we'll go ahead and choose that and say OK. And then all we do is add the text file that's normally outputted from our CMM machine. In this case, here's our first one, so we'll go ahead and click Open here. And by default, all it does is read in the data and parse it so that it can filter through and identify what's a linear dimension, what's a radius dimension, what's a perpendicularity, what's a profile of the surface. And then what we do is go ahead and match those up. Now, we could do this manually, or we have the button here in the CMM Data Import section called Auto Assign. So that's what we're going to try first. We'll go to Auto Assign, and these checkboxes that you see here are exclusive filters. And what we mean by that is that if we have all the checkboxes turned on, any of the characteristic values that are out in the drawing have to match every single one of those different options by an exact match in order for it to be paired up with one of the results from our CMM data. Otherwise, it's only going to look at the parameter for which you have a checkbox toggled on for. Item number is the order in which the nominal values were recorded in the CMM program. So if you measured all of your dimensions on the part in the same order that you recorded all the characteristic balloons on the PDF, then you could ignore everything and just go by item number, because the first characteristic balloon in your PDF would match with the first measured value in your CMM program. That said, not everybody has the time or the energy to make sure that those match up. So for that reason, in our example, we're going to uncheck item number. We're going to ignore whatever order that these values were recorded in, and instead we're only going to look at the type of dimension, the nominal value, and the upper and lower tolerances, and all of those together have to be an exact match before we're going to see a characteristic balloon and one of the measured results in the CMM data match up. So let's go ahead and say OK here via the green check mark. We're going to overwrite any previous results. And what you see there is any of the dimensions in the drawing, the nominals, if they have an exact match by both the value and the tolerances to the data that's in our CMM report, then they go ahead and get this color coding of whether or not they passed or failed. Now there are a couple in here that it didn't find, in this case the profile of our surface, that GD&T frame. If any of those don't map, we can go ahead and come here to the type of dimension that it is, and we can actually find that profile of a surface because the data was parsed, and so it recognizes that there are some of those of that type. And so we can see here that there is an item number 6. It has a profile 0.02 with references to ABC, and all of these points were measured for that particular value. So what we can do is select that GD&T balloon, and then we can select all of these data points, and we can right-click and assign these results to the selected characteristic, and then of course we'll get our color coding. Now if you click on this drop-down arrow, this is where we see all of those different points that are being added to that single cell. And whether or not it passes or fails is going to depend on whatever option you have set in your template. If we go to our application options and come down to measurements input, you'll see that under display, we have the multiple measurement display options. And in this case, it's looking at all of those data points and seeing if the average case is going to fall within the upper and lower limits. But we can also do worst case and best case, or just worst case. And so in our case, if any of those points is really outside of tolerance or very close, we'll actually see that with more detail than if we did just the average. So let's switch that option and let's see if that changes any of our results. And it sure does. Now we look at that profile of a surface, and even though the average is acceptable, we still have a value that's very, very close to the upper or lower limit in the case of the worst case. And so that's why it gets a yellow. It still passes, but not with flying colors. If we had more data that we wanted to import, perhaps we ran another part through the inspection process, we can then go up to Add Files and add additional text files that represent another run of the part through the CMM program. When we do that, we see that in the second example, one of our worst case points was outside of the limits, and therefore that second part fails. And if this trend continued, we might surmise that that profile of a surface is very difficult to keep within tolerance, or perhaps we'll switch to an average, in which case the tolerance would be a little bit looser because maybe 1 or 2 points are out of tolerance, but the vast majority of that curved slot falls within tolerance. In this manner, we can go ahead and map out all of the different CMM machine program results to the nominal values, and then when we're finished, we can go ahead and come up here to PDF and Excel and generate the same kinds of reports that we had earlier, but with all of our results already included. So first we're going to get our PDF that has the results already color-coded and placed on the drawing. And then we'll get our Excel report, and in this case we'll choose the M-Expert option that's going to include all of our color-coded results. And now we can see the new report along with all of the data for both parts, and we can see here that if it's a multiple point measurement, it includes all of those points as part of the results. So these are the different features and enhancements that are included with SOLIDWORKS Inspection Professional. If you would like to know more, or if you'd like to see a live demo, be sure to contact your VAR or your sales representative.